Welcome back to the Mechanics of Solids lecture series. In this series of videos, we're looking at examples that use generalized Hooke's law. This next example is an extension of the previous video. We already worked this problem to completion in the previous video. However, this video will provide additional information on how to solve the simultaneous system of equations without using a matrix solver by hand manipulation. And if we were just to proceed with a straightforward brute force approach to solving these equations, the math can be quite ugly. However, if we're clever and we approach the problem correctly, we can make the math really quite easy in this case. So the purpose for doing this is to help provide you with some intuition as to how to do that. I'm going to label these equations: equation 1, equation 2, equation 3. Equation 2 is a gimme. This one is very easy. We observe that epsilon x and gamma xy drop out of the equation. So equation 2 allows us to solve directly for epsilon y. 735 equals 1 times epsilon y. That one's easy. And the units are microstrains. So sorry, I should write epsilon y equals 735 microstrains. Okay? Now, notice equations 1 and equation 3, I have some symmetry. But epsilon x is multiplied by 0.75 in both equations. And gamma xy is multiplied by 0.433, positive in one equation, negative in the next equation. Okay? I'm not going to use equation 2 anymore, that's why I crossed it out. Notice what happens if I add equations 1 and 3. I'll have negative 300 plus 410 equals 0.75 plus 0.75, or 1.5 times epsilon x, plus 0.25, 0.5 times epsilon y, which we already know, and then 0.433 minus 0.433 gamma xy. Gamma xy cancels out of the equation. Solve directly for epsilon x equals negative 300 plus 410 minus 0.5 times epsilon y, 735, and the whole thing divided by 1.5. And this computes to epsilon x equals negative 171.7, and the units would be microstrains. Okay? Now look what happens if I take equation 1 minus 3. In that case, 0.75 minus 0.75, epsilon x will cancel out, epsilon y will cancel out, and we can solve directly for gamma xy. I have negative 300 minus 410 equals 0.433 minus a negative, so a positive 0.433. I'll write that as 2 times 0.433 times gamma xy. Now I can solve for gamma xy directly, equal to negative 300 minus 410 divided by 2 times 0.433, and this is negative 819.9 microstrains. Okay? So this is an approach you can take to manipulate the system of equations to solve for the strain state. As I mentioned in the previous video and would like to emphasize, the easiest method is to set up the system of equations and solve it using a matrix equation solver. But if that is not a tool at your disposal, this is a good backup approach that's fairly efficient. That concludes this video.